Now, normally the compass can't dip down into the earth. It wants to dip down into the earth when you're away from the equator. Normally it can't dip down into the earth because it's on an axis. But when you accelerate the compass, you change the axis the compass is on. So let's accelerate this compass, and you see you change the axis the compass is on, and now it tilts, and therefore the compass can rotate around the axis and dip down into the earth. And that's what happens, and the compass now shows a turn towards the heading of north during that period of acceleration. Okay, now let's take a look at deceleration. Now you're on an easterly or westerly heading again, and here's an example they're going to give to you on the test about this. If you decelerate the aircraft on an easterly or westerly heading, the compass will indicate a turn towards the heading of south. And decelerate south, decelerate south. Now let's take a look at why that happens one more time. Once again, you're tilting the axis the compass is on when you decelerate. You're slowing the airplane down, the compass swings ahead, and now the north sensing arrow can rotate around this new axis, dip down into the earth, and during that period of deceleration, the compass shows a turn towards the heading of south. Now, what's the word we use to remember all of this? Well, it's the very next thing we want to talk about, and that word is ands. Accelerate north, decelerate south, as in no ands, ors, ifs, or buts about it. Okay, now let's take a look at the next thing we want to talk about, and that is compass turning errors. And compass turning errors occur only on north and south headings, and here's the way they work. If you're on a heading of north and you start a turn in one direction, the compass momentarily indicates a turn in the opposite direction. And the word we use to remember that is the word no, north opposite. If you're on a heading of north and you start a turn in one direction, the compass momentarily indicates a turn in the opposite direction. All right, now let's assume you and I are on a heading of north and we start a left-hand turn. Well, what's going to happen? The compass will indicate initially a turn towards the right, and that'll be to the east, and here is why. Let's see if we can take a look at why. If you're on a heading of north, what you do is you bank the airplane when you start that left-hand turn. So let's go ahead and start a turn. Well, we'll do a turn to the right. We'll start a turn to the right. We bank the airplane, and what happens because you've tilted the axis the compass is on, it can rotate around that axis, and the north sensing arrow dips down, and the compass momentarily shows a turn in the opposite direction. Let's do one more example. This time, let's assume you and I are in a heading of north, and we start a right turn. The compass will momentarily indicate a turn towards the left or to the west, just as exactly as we have shown right here. And those are called compass turning errors. Well, now let's talk about how you're going to remember this. Well, as you remember, these compass turning errors occur in turns near headings of north and south. You already know about no north opposite. So if you start a turn on a heading of north, the compass will momentarily indicate a turn in the opposite direction. But here's something else the compass does. In turns near headings of north, the compass kind of lags behind the nose of the aircraft. It undershoots the nose of the aircraft, so it undershoots in turns near headings of north. But on the other hand, if you're in a turn near a heading of south, the compass overshoots or goes too fast. And the word I use to remember that is the word we're all very familiar with, cosin. I'm sorry, I have absolutely no idea what in Sam Hill the word cosin means. It's a word I made up to help remember the compass overshoots in turns near headings of south and undershoots in turns near headings of north. Now let's take a look at how it works on a turn near a heading of south. You're on a heading of south, you start a turn to the right. What's going to happen is the compass will jump ahead faster than your rate of turn. So if you're on a heading of south and you start a turn to the right, the compass will indicate a turn to the right, but at a much faster rate. So if you start what they call a standard rate turn, about 3 degrees a second, and you start that turn, what you'll see is your magnetic compass will show a turn to the right, but much faster than that 3 degrees a second you're trying to do. So let's go back and review this one more time. First of all, NO is north opposite, and remember the compass overshoots in turns near headings of south and undershoots in turns near headings of north, and the word you're going to use to remember that is a word we're all very familiar with, cosin.